a one unique number to each and every, you can say, word, right? And all my sentences throughout on the internet, all my articles, all my web pages, you imagine every data which is present in text is the permutation and combination of my these words only, right? So that is where model needs to break down my entire thing into single tokens, right? All my words is known as tokens here, which is known as the tokenization, right? That's the first step. So model will break down my input into tokens and bring all the numeric token IDs what it has, right? That's the first step. And why it has to do, because all my costing is also associated, right? We don't know about the costing much on the front end applications, which is chat gpt and other tools. But when you go and build your own applications using something called apis, which you will be learning by the way in your next session, I think tomorrow's session or maybe today's session, you have that api concept also coming in. So when you build your own applications, you need or your cost is associated with all these tokens, right? How many tokens you are utilizing, so model needs to take care of that. Okay, so that's my first step. We are clear that why we need to do and how it happens. We have already seen that. Second step is my very important, which is known as embeddings, whose job is to convert now these tokens into numerical vector so that my meaning of these words get introduced into my model, right? So in my first step there was just a concept of breaking down of my words into tokens. The job of my embedding model, right, it is also a model by the way, right? So we don't know because we use the front end application, but at the back end, right, at the back end of chat gpt, there is an embedding model whose job is to bring the meaning of my ask into the picture, right? Whatever I have asked on chat gpt, it will try to bring a numerical vector associated with that word, right? So like if we have given an input, explain me about large language model, it will bring the numerical vector for explain, the word me, the large language model, all of that meaning is coming into the picture via this model, right? Again, I'll show you visually so that you have the you have some image in your mind, right? And you can remember from it that how the embeddings actually work. And I'll give you two sentences. You will be very much clear about this, right? So these are all my words in English language, right? They are, I mean, just 10,000. They have filtered it out. So these are my 10,000 words which are plotted in three dimensions. Now, right, I can see all the words which are. I'm just hovering my mouse. I'll give you two sentences, and you will understand this whole embedding process. So my sentence one is, I am eating a delicious apple, and second sentence is, I am using an Apple iPhone, right? How does model understood about which Apple I am talking about, right? Because it has learned all the context from the internet, right? So it knows that there is an Apple fruit and there is an Apple brand, right? Why? Because there are certain words which are only associated with my apple as a fruit, and certain words are only associated with the apple as a brand, right? For example, stock price of apple. So if I'm asking stock price of apple, if I just google search this, all the articles now it will come, right? Let's say top 10 articles, just thinking, right? Just think logically that if I just google search right now stock price of apple, and whatever top 10 links I get from google will only be associated with the brand apple, right? It will only with the brand apple. And if I type this query, uh, how many calories I have in apple, right? It will always be, right? All the 10, 20 links of my starting page, the word calorie, I mean, it can associate it with an Apple Watch also, right? But if I'm asking how many calories are in apple, that means the user is talking about a fruit apple, right? So model can distinguish those patterns, and if you can see, right, near words, Macintosh, Windows, Mac, Intel, all these my words are near, or you can say are used alongside with apple, right? And that is why the job of embedding model is to bring the clear cut meaning into my picture, right? So those two steps are done: tokenization, embedding. Third step, really again very important, right? Self attention. As model says, I mean, as the definition says, the model focuses on only important part in my text, right? Or I would say model give more weightage to some part of my input sentence so that it knows what the user is actually asking, and it happens automatically, right? Again, I'll show you with the example so that we have the entire representation how it actually works, right? So the third step is self attention, which automatically focuses on which part of my input I should focus on based on the user query, right? So now I asked, like in my first response, I asked this thing, can you explain me about LLM? And it has given me a technical definition. I'll copy this exact same sentence. I'll go to a new window, right? I'll just paste it. Explain me about LLM as if I am 5 year old, right? So if you see that I have just added this particular line, right? But now my response will totally be changed, right? It will be changed totally, and model itself focuses on this part that I have to give the definition of LLM, but not a technical one, as if I have to explain it to a 5 year old kid, right? And that's the beauty of self attention, which give more weightage to some part of my input automatically, right? It's all mathematics at the back end, right? I'm not going into the mathematics. We have a lot of transformer architecture, science going behind. We have key value vector, query vector, value KQV vector, multiplications going on. So that's a whole technical stuff. But if you understand logically what is happening, it is giving more importance to some words in my input sentence. And now if you see the definition, imagine you have a super big big toy box inside the millions and millions of toys, so many no one could count them all, right? All of this is coming. That's what an LLM is. So now if I go and explain it to an 5 year old kid, he or she will be able to understand this definition, right? So that is what is happening in my self attention part. And now the fourth step is how the model is giving me the output, right? So the first three steps, tokenization, embedding, and self-attention, belongs to my input part, right? Whatever we ask on ChatGPT, those three steps are contributed towards my ask. The next step, fourth step, right? We have only 5 steps. We are on fourth step right now. It is on the output side, right? Models start giving me the output. And this is very, very simple to understand. I'll start with the example and then explain you how the science behind this step is working. Right? So you give me the response now that if I have this sentence, imagine you have a super smart robot friend who has read every dash. What all words can fit in this dash, right? One possible word is book. Can you give me few other words in the chat apart from book and bank? What all can fit, right? Blogs, yes. Article, mind, newspaper, novel, journal, poem, website, magazine, perfect, right? Journal, books, perfect, right? I think you got a great understanding of this step, what I wanted to have this exercise to be done. So now go back, right? Go back to your thinking what exactly you have done, right? How did you perform this exercise, right? Same way AI also does. So what you did, you went back into your brain and thought, what can be the possible words that I can fit in here, right? That I can predict in here. And you gave me newspaper, magazine, poem, journal, all these words which can fit in this sentence, you gave me as an output, right? So that's what model does. Same, right? Model has limited, right? We have finite set of words. We all know now it's a finite set. Model assigns a probability to each and every word. So that's the job of model, that it assigns the probability between 0 to 1, right? We all know probability is a mathematical, very beautiful subject, I would say, right? So it's a mathematical model which is giving the probability output. So it assigns each and every word a probability, and now model picks it up from those high probability words, right? So maybe book is having a probability of 0.6, right? Newspaper is having a probability of, let's say, 0.4. But have you given me any other word which doesn't fit in this context? Let's say the word, let's say democratic, right? Imagine you have a super smart robot friend who has read every democratic, right? It doesn't make sense. So the probability of word democratic will be 0.001. Or let's say table, right? I'm having my laptop in on top of table, so I got this word table. right? The probability of word table will be 0.0001. Why? Because it doesn't make sense who has read every table, right? No sense. That is how the model assigns the probability, and it keeps on predicting the next word that can be fit in unless and until I get my response back. Right? All my response get back. So it